convert fractions and decimals. So the fraction bar represents division. And then to convert a fraction to a decimal, we're going to go ahead and divide. And then if the decimal repeats, we're going to use a bar to represent that. So if we had an answer that went like this, 0.11111, and just continuously went on with ones, right? Well, we would represent that as 0.1, and we could just put a fraction bar over that 1, because that bar represents that decimal repeats on forever. So now let's go ahead and look at the example 1. So there's two motors rated at 1/8 horsepower and 1/3 horsepower. So what is the decimal equivalent for 1/8? So all we're going to do is look at that fraction bar, and we're going to go ahead and say that's a division problem. We're going to go ahead and divide. So how we do this is we're going to go 8 into 1. Well, 8 can't go into 1 because 1 is smaller than 8. So we can just go ahead and add a decimal. And we're going to add, say, 2 zeros after the decimal. And we'll see how many we need. So 8 now can go into not 1, but it can go into 10, we can say. 8 can go into 10 one time. So let's go ahead and bring that decimal straight up. Now 8 times 1 is 8. We go ahead and subtract. 10 minus 8 is 2. Now we're going to go ahead and carry down that 0. Now 8 can go into 20 2 times. So now we have a 2 on top of that second 0. 8 times 2 is 16. We go ahead and subtract. We get 4. Now we can go ahead and just add another 0. Go ahead and bring that down. Now 8 can go into 40. 5 times exactly. So when we go ahead and subtract, we get 0. So we're left with our answer, because we don't have to do any more, as 0.125. We can even go 0, 1.25, and that would be our solution. Now let's go ahead and do the decimal equivalent for 1/3. So let's just kind of do it right here. So we're going to go, we have another 1 inside, and we have a 3 now on the outside. 3 can't go into 1, but let's go ahead and add some zeros. So we have the decimal. We'll go ahead and bring that straight up. Now 3 can't go into 1, but it can go into 10, right? If you look at these two numbers 3 times. So 3 times 3, well, that's 9. Well, 10 then minus 9 is equal to 1. Go ahead and bring down that 0. Well, 3 can go into 10, once again, 3 times. So 3 times 3 is 9. Subtract, we get 1. Notice how, look at this. We keep going, and we keep ending up with 10 on the bottom. So we can keep going on and on, right? Because 3 times 3 is 9. We subtract, we get 1. Then we can go ahead and bring down another 0. But instead, we're going to notice that this is going to go 0.333 and continuously go on with all the 3's. So we're just going to go ahead and represent this as 0.3 with a bar over it. Right? This bar is very important. So that's our solution. Now let's go ahead and look at the next example. So example 2. We're going to convert decimals to fractions. So what we're going to do is actually put the decimal over 1. That's our first step. The second step is we're going to multiply 10 on both the top and the bottom numbers for each number there is after the decimal. And we're going to reduce if possible. So let's look at this. So a diode in a circuit has a current of 0.375 amps. What is this expressed as a fraction? So let's go ahead and take this number, right? And we're going to go ahead and put it over 1. So that's our first step. Then we're going to multiply it by 10 for every number after the decimal. So there is 1, 2, 3. So that means there's 3 numbers. We need to go ahead and multiply it by then, right? We can do it 3 times. We can go times 10. So 3 times, well, 10 times 10 is 100, times another 10 is 1,000. So all we're doing is really multiplying this number by 1,000. And then another way to think about this is we're then moving the decimal over 3 times, right? For every time we multiply, we move the decimal over 1. So what would that look like, right? Well, we would end up with, if we want to go ahead, let's just go ahead and rewrite this. We can show 375 over 1,000, because we moved the decimal over 3 times, because every time you multiply it by 10, you move it over 1, then 2, and then 3. And then we do the same on the bottom. Right? So that's one way. Let's just go back. So what if we just went ahead and did this? Right? So we did it, we know this is 1,000. So let's go ahead and let's go ahead and write 1,000 on the top and then 375. But we could also do that trick that we know, right, where we put the 0.375 and then we put the 1,000 out, and then we just go ahead and bring down those zeros. I don't know if you've ever seen this trick, but it's a very nice one when you just have zeros out there. And then you just multiply this and act like it's just right there. So 1 times 5, 5, 1 times 7, 7, 1 times 3 is 3. Now we go ahead and move the decimal over 3, because we have 3 decimals there, and we get 375. Now, 1 times 1,000 is just going to be 1,000, because 1 times anything is going to be what that was, right? 1 times something is going to equal that something. So we have 375 over 1,000. But we can go ahead and reduce this. So let's go ahead and reduce. So we notice that this ends in a 75. So that means we can go ahead and divide the top and the bottom by 25. So if we were to go ahead and write this out here, 25, this can go into 1 time. We subtract, we get 12, bring down the 5. Well, 25 can go into 125 5 times. We go ahead and subtract and we get 0. So we get 15 on the top then. Now 1,000 divided by 25. Well, 25 can't go into 10, but it can go into 100 4 times. We subtract, because 24 times 4 is 100. We get 0, bring down the other 0. We can't do anything more, so we just get 0. Right? And 25 times 0 is 0, and we subtract, we get 0. So on the bottom, it's 40. Notice, once again, it ends in a 5 and a 0, so let's go ahead and divide by 5 on the top and bottom. So 15 divided by 5 is 3. 40 divided by 5 is 8. So 3/8 would be our fraction. We go back up here, we write that there. So that is our solution. So notice there was a couple ways we could have done it, right? We could have multiplied it, each number, right? We could have multiplied this 0.375 over 1 and then multiply by 10 on both top and bottom. So we get 3.75 over 10, and then just keep going, right? Just done this on each individual multiplication. Or we could have remembered that every time you multiply a number by 10, you move the decimal over just one spot. So there's a couple of ways that we could think this through. And there's not one right way to get to the answer. So there's that one. So let's go ahead and look at the next example. So example 3. So we have a coil in a circuit that has a current of 0.75 amps. So what is this expressed as a fraction? Well, we have 0.75. First step, we put it over 1. We do have 2 decimals, so we're going to go ahead and multiply it by 10 twice. Right? So that's the same. 10 times 10 is multiplying it by 100. So 0.75 times 100. So what do we get? Right, we multiply what's on the bottom. So that's going to be 1 times 100, so that's 100. Now 0.75 times 100, right, if we were to do it like this, you have those zeros hanging out, we just bring them straight down, 5 and 7, move the decimal twice, we get 75. So we get 75 over 100. Another way to think about that when we reduce it, right, is we're going to go ahead and divide it by 25. So essentially, right, you think about it in terms of like quarters. If you have 75 cents divided by 25, because that's how much, say, each quarter is worth, how many do you have left? Well, that would be 3 on the top and 4 on the bottom. Because 75 divided by 25 is equal to 3, and 100 divided by 25 is equal to 4. So just kind of a different way to think about it, but that would be our solution.